So in this chapter, we are going to learn about the performance comparison in between CPU, GPU, and TPU. So what I'm trying to do here is I took an MNIST dataset. This dataset consists of handwritten numbers from 0 to 9. And that numbers, the dataset consists of close to 60,000 handwritten images of those numbers. So what it tries to do it is take those 60,000 numeric handwritten images, it trains a model and it evaluates against another 10,000 test data, which is of same type, again handwritten content, and it is a labeled data. Labeled, when I say it is basically a actual number which is written, handwritten, and what is that number if we, what that number means actually. Someone, human went and someone did that exercise by looking at those handwritten content and identified that it is a number, a proper number actually. And after training, as it gives a during most of these entire training, model training as well as testing process, it gives an accuracy close to 98.66%. Okay. So what I did it is to have an apple to apple comparison. I modified the same, I took the same data set, but some of the libraries I modified to make sure those are ready to run on GPU and TPU. Basically, there are certain libraries needs to be there for TPU as well as some of the GPU CUDA models. Libraries are needed to make sure that they work efficiently, as well as we have initialized the underlying infrastructure also properly to make sure that entire model training process happens as well as testing process happens on the particular infrastructure. So, and at the same time, I made sure that I changed the runtimes also and make those runtimes available for this entire model is actually generation process as well as testing process also. So without a further delay, let's directly jump on to how I did it and what is the real difference in terms of CPU, GPU, and TPU. So so let's see. So this program you have already seen. This is just a sample program. I have already explained it in earlier videos about how to verify whether the underlying infrastructure is proper or not. Okay, to just to make sure that you have a GPU available. This is something you need it when you are running locally. You want to make sure that GPU is available for you. Okay, that's what I'm trying to do it here. So here what I did it is, like I was mentioning, the first thing I did it was I ran it on a CPU. You can see that CPU has 12.7 GB of RAM and I have 107 GB of disk space available. And it took me to train the entire model, okay, and test the model close to 7 minutes and 8 seconds. I haven't changed anything related to model generation or model creation process, as well as model testing process or any of the data. And I could find out that the time it took close to run on this particular CPU from training to testing end to end is it took me 7 minutes and 8 seconds. So I did the similar exercise, okay, on a GPU. I made sure that I did all these experiments in Google Colab because that's where I have a GPU as well as TPU, and as you know, TPUs are only available on Google Cloud only, and through Colab you can make use of them. So I changed it to GPU, okay, my runtime also, and programmatically also I started using some of the GPU related libraries also. And I ran the same program, same data set, and it took me close to 44 seconds. So you can see that what a vast difference is there. While in CPU it took 7 minutes and some seconds, while here it took 44 seconds to run and test, generate the model. It took like 44 seconds. Okay, I haven't changed any of the steps basically. While I did it is I changed the runtime to TPU. Some of the TPU related, some of the libraries I have added and some of the APIs I have used to initialize the TPU system. And I reran the same program. As you can see, that RAM disk space is same, but this time I made sure that it is a TPU is there. Okay, and I reran the entire program, and it took me close to 2 minutes and 20 seconds. I haven't changed anything, the number of cycles, batches, and everything I left the same. But I reran it, and you will see that it took me 2 minutes and 20 seconds. Again, this is just a sample program to make sure that if the underlying infrastructure is a TPU or not. So overall, if you see that my CPU running took close to 7 minutes and some number of seconds, and while the GPU took 44 seconds and TPU took 2 minutes and 20 seconds. Even though Google says that there are certain guidelines for the TPUs for a particular workload when you wanted to run. Again, if without you using much of your brain and all the guidelines to what kind of data set or what kind of model you should be training on TPU to get the maximum performance, if you try to run it, the GPU will be by default will offer you the best kind of performance, at least for now, at least this kind of problem where this is a classification problem where we are trying to classify the numeric values, handwritten values into a numeric numbers actually. So as you can see, this is the comparison, and I can see without much of a too much getting into the guidelines, I could see that the GPU gives a better performance. So this is something I wanted to show. We'll go in detail about each library we are using, what is the steps happening in this, and we will try to see under the hood also what happens in during the each step, and what is the model, what the model generation in subsequent chapter. For now, you just remember that this is the comparison and what a CPU, GPU, and TPU offers to you. I did write an article where I did compare LPUs also. I couldn't exactly miss try this workload on LPU. You can go to my blog, sachinkapai.blog, and you will see that I recently published the LPU output also. Okay, but not related to, I couldn't run the similar example over there. But you will see that the performance of the TPU is extremely high. The transaction time, basically, you will get an immediate response, while when you are running it on a chat GPT or any of this, it takes time. You can see that for generating like close to these many number of tokens, like 890 tokens, it took 1.78 seconds actually. So that's the LPU, and that we will talk more about it. But if you see that there's the token response time is very, very low actually, as compared to even running on GPU or TPU. At least that's what my early understanding while running it in the developer playground on LPU. So with that, stay tuned for the next chapter. We'll learn more about it. Thank you.